Okay, so do you want to start with the first biggie, the big one?
Question. It's the big one.
What is a high performance home? So a high performance home is going to be a home that is comfortable, durable, energy efficient, and I know what you're going to say. I'm not going to say it because I know you're going to say it. But it also makes you happy to be in the home, healthy. So you want to add to that?
So it's healthy in the home.
Yeah.
Yeah. I was going to say it's simple, which means that it's easy to take care of.
Oh, yeah.
And it lasts a really long time. And it's comfortable, and it's safe, and it's healthy, and it requires as little resources as possible from outside of itself to operate, which is especially important in our day today because we're using resources that are oftentimes coming from other parts of the country or the world or the state that we're using for our benefit. And also, we're making a simple machine that is also simple to operate.
Yeah, it is. A house is kind of like a machine. And I would say that you would think, all right, well, that's any house, right? Any house is comfortable, durable, easy to take care of. No, it's not. Energy efficient. And I would say, no, it's not. And even a recently built house is not necessarily all of those things.
Criminal, absolutely criminal.
I don't go there, but I would say that they can be lacking definitely in their efficiency because maybe something wasn't installed properly. The good news is that Washington State Energy Code is requiring builders be way more efficient in how they put their assemblies together, and it's just only going to get better over the next 10 years. It's going to get more stringent. So I would say that's a good thing, but if it's not installed right, it will fail. For instance, if you're depending on your air barrier to help keep your envelope working properly and somebody doesn't install it right, now you've got leaks and it's air washing the insulation and the insulation can't do its job. So the thing that Chris pointed out that Mike Feeney said in a recent blog post, where the architect on staff here was asked, what is your definition of a high performance home? And he said a lot of this, of course, but he also said it's where you're happy. So that's sort of interesting. What is it that makes you happy in your home?
Yeah.
Is it the comfort? Is it feeling like what you purchased was good for the planet? What is it?
Got a good value.
Yeah. Or is it like that you have a really big TV and good speakers?
And a hot tub to watch it from.
Yeah. That's all part of it too. That makes people happy. But installing all of those things or having the blocking in the wall, it's all part of a high performance home, that it's done well.
I'm going to point out something that Maggie has said often in the past. A house that's built to be beautiful is most frequently a house that's taken care of. Mm-hmm. So a house that someone finds is comfortable and safe and they like to go home to, they're likely to take care of it for a longer period of time, which is good because that means it doesn't end up in a hole in the ground or in someone's oven when they're tired of it.
Yeah.
It lasts longer. That's an important part of a high performance home from a sort of resource use point of view.
Right.
But I think we're going to get kind of techie in a second here.
Oh, with the other questions? Yeah, for sure. Yeah, there's some really cool things about a high performance home that I love talking about. Ooh, let's see, what is it? What are you ready for me to go?
I think we should jump into the big question because everything else sort of falls underneath that question.
Stay on this one for a minute. Well, okay, so
everything else
if I was going to define like the systems of a high performance home, I would say that everything is based on electric energy. And so you've got a heat pump to heat the air in the house. You've got a heat pump or the if you're not heating the air, you're heating a hydronic system. They're now making those. That's recently something that we've seen.
Using the same technology as
Heat pump. Yeah, hydronic used to not be available with heat pump, but it is now. And you can also have that hydronic go into old-fashioned radiators underneath the window, like, you know. So you'd have a heat pump to heat the air or make you comfortable, and also to heat your water. You'll have a heat pump for that. You also have a heat pump to dry your clothes. Your kitchen appliances will be Energy Star rated, including your stove, which would be induction range. Yeah. I almost totally blew that.
She was so close to the edge right there.
Induction range, or stovetop and cooktop. And there are some, there's a couple appliances you cannot get in Energy Star. And one of them normally is a dryer. But if you get a heat pump dryer, I think that is about the only type of appliance dryer that is Energy Star rated.
Yeah. So you're really talking about mechanical systems.
Yeah.
And so on that list that we just talked about, in terms of the kind of resources that the building is using, then the stuff inside that's using resources, namely electricity or gas, whatever, is really important. You're sort of pointing to those things.
Yeah. The one, I just wrote it down because I didn't want to forget. The other appliance or mechanical system that is really important to a high performance house, if you're building a new one, is an HRV, a heat recovery ventilator. In our area, that's what you would use. If you were living in the South, you would get an ERV, which is an energy recovery ventilator. So it's not a system to heat your house, even though the word heat is in it. It's a heat recovery ventilator. So you're taking polluted air out of your house and you're bringing fresh air in your house. But when you as the warm polluted air passes out of the house and the fresh air comes in, there is a heat recovery ventilator. It's a little machine, and it doesn't mix the air. It doesn't mix the air, but the air does pass through chambers next to each other, and the heat is extracted from the air that is leaving the building, and it's transferred over to the air that's coming in the building. Yes, it's magic. So heat recovery ventilator is really, really important to a high performance house because of the health issues.
So you're ticking off the healthy box.
Yeah. It's got a filter in it up to I would recommend up to a MERV 13 will take care of any allergens that could come in. It takes care of smoke. They're quite amazing at keeping your home full of fresh air without opening all the doors and windows, because you can't do that all the time. There's times of the year where it's just too cold to do that. So
that's the healthy and safe part of a high performance list. We were just talking about the energy efficient or low resource use when we're talking about the quality of the components inside of the building. And now we're going to talk about, we talked about the make you happy thing. And then, so we've got this whole question of sort of durability and long lasting sort of thing.
I define an envelope as basically everything to do with the exterior of the building, the very exterior of the building. So it's going to take in the roofing, the siding or cladding or stucco, whatever you have on the side of your walls. It's going to take in all the windows and doors, the fenestration, and then all of the gaps between those things are part of your envelope, and you don't want gaps. So you want to have those all sealed. And then you're also going to wrap that down to your foundation, whatever that assembly is. You're going to continue that envelope. And think of an envelope, a sealed envelope,
Like a balloon.
Like a balloon, yeah.
It's a balloon.
It is. It's like a balloon. You make a balloon for your building. And then by using the heat recovery ventilator in there, you can have a super airtight house, and you don't have to worry about asthma and allergens and things because you've got fresh air constantly circulating through the house.
There's another way to think about the envelope of a building. It's the shell of the building. It's the exterior surfaces. What's underneath, what's around, what's on top. But another way that we think about this is, because we've worked on thousands and thousands of buildings in Whatcom County, and we see commonly repeated mistakes and failures that have led to other more significant structural damage or other health concerns. But basically, I rate houses on this continuum, and on the left side of the continuum is a soggy paper bag. We've all probably lived in a soggy paper bag at some point in our life and called it a house. And on the other end of the spectrum is really what we want to build, which is really like the best cooler you have ever used. So you put one can of cold beer in there, and all of the other cans of cold beer get cold and stay cold for days and days and days and days, without introducing any additional energy to change the temperature. So in an ideal world, we're building envelopes that are airtight and hyper insulated. Airtight, watertight, and hyper insulated. And so it takes very, very little energy / resources to affect the indoor temperature of that building. So it takes as little energy as possible to raise it up to a comfortable level, and that comfortable level stays that way for as long as possible before we have to introduce any additional energy to change that temperature back to the comfortable level. Mm-hmm. And so that's how I think about a building envelope, is how do we make the shell of a building like a thermos, basically.
Mm-hmm.
Yeah.
But we missed sort of a really big one on the overall definition, because we get fixated a lot of times on the building, the structure itself. I mean, just roof, walls, and foundation. But integrating that with the site is super, and the sun is super important. Yeah. And so that is also a big part, how you orient the roof, what kind of pitch you have, how much attic space are you building that is not going to be used at all, how high are, so.
But the nature of the envelope from a performance point of view, whether it's a box or a cylinder or a circle or a pointy thing, mm-hmm. It doesn't really matter. It's the nature, the thermal quality of that envelope and the ability to keep out the weather and mm-hmm. to keep in the energy you've used to cool or heat that building is critical when you start asking the question about the resources that it's using. Because if you don't build a house like that, solar panels are not going to add very much. Mm-hmm. Putting solar panels on a 1914 Victorian in Bellingham, Washington are going to do nothing but give money to the people that put the solar panels on your house. If the house is not addressed, if the thermal quality of the house, the envelope is not addressed in that house, those panels will not perform to expectation. But it also applies to the things inside that house that are using energy. So all of that stuff has to be thought together. It has to be thought of as an integrated system and be thought of together when you're either designing a new one or when you're changing.